Okay, so we're back, and what we're going to do now is we are going to take a look at how to take these and put them into our Java code. Okay, so there's a lot of different theories about how to take even a small system like this and what the best way is to go through all the process of where should you start? Should you start at store? Should you start at product? Should you start at, where should you start? And there's a lot of different ways to do it. So what we'll do for today, for me, is we will just go top down. We'll go ahead and start with the store, and then we will come back to the store as things need to get added. Okay, so let's go ahead and just take that first class, this store class, and create it. So I've gone ahead and done this little skeleton here, this midterm example. Let me increase the font size just a little bit. If it ever decides to come up, okay. Okay, so we got a bigger font now, right? So what we're going to do is we're going to create a class called store. And we had these private attributes called name and address that were both strings. So now we just create a private string name. You can either do it name address like that. You could do not address. You could do name and then private string. Either way, okay. We need a constructor, right? Wait, first of all, does this class have a constructor at this point, or do we need to make one? Are we required to make a constructor? Yes, we're required to, or yes, there is one. Right, there is one, the default one, remember? And what it looks like is, if we didn't type anything at all, this is what we would get, right? This is what's already there, even if we don't put anything in here. But this is probably not the best thing for us to do for our store, right? We probably need to have wrong way, other way. Now, some of you, so what I did was I basically said, okay, I'm going to take my two attributes, and I am going to make those my constructor parameters. Okay. All right. So some of you may be saying to yourself, wait a second, I've not seen this before, this name equals name in before. Okay. I've done this before. There's a couple of different ways that some people do their methods, like their their set methods and their constructors and other things like this. Is for something like this, we could either have some special parameter name and take that as being the thing that we assign to this. But the thing is that we need some way to make sure that the compiler, and when the code executes, that it knows there's a difference between this and this, that we're taking this value and putting it here. So some people will do it this way, putting some in, or some other special character on the end here or something like that. Some people will just pass in parameters that have the same name as this, and then here in the method itself is they will add the keyword this here. Okay. Again, two different ways to do the same thing. There's not a big difference between those two. Okay. All right. So we created our store, right? We're done. All right. Now we need to have some type of collection for our customers and some type of collection for our products, but we'll get to that in just a moment. We're just going to create the classes themselves first. So then customer. That has a parameter name. Oh, that should be, all of these should be minuses. All right. Let's see if this compiles and creates our classes that we're expecting. Oh, there's a compiler error. What? Oh, that's public. There we go. There we go. Customer class, store class. Good, we got it. Okay, so now this is where we have a little bit of fun, right? Because now we need to create this club customer, but we have to extend customer, right? Not public. What was a private phone is a string. Now, should we have our constructor just be with the phone number? Should we do this? Should we do just our club customer just has a phone number? Or do you think that there's something that's missing? What's missing? What would happen if we did this? Okay, so should we do this? So you're saying we should do like that? It needs a parameter. What parameter does it need? Name, but how do we get the name? How do we get the name for our club customer? It's a tough one, isn't it? The name of the, like, phone, like that. Right, the phone number is going to serve, Arjun, I don't know if I said this in the previous hour, but the phone number will serve as their number or code for their membership. All right, yeah, so what we'll want to do is we'll want to modify the club customer constructor so that we take their name as a parameter also. This is what happens a lot of times with these classes that extend other classes, is they take not only the parameter that's needed for that specific class, they also take the parameters for the parent classes as well. Okay. So there we go. So we call the super constructor with the name parameter, and we call this one. Good. Make sure it builds. Good. Okay. So here we got this whole side of this done. Now what about our product? Does it extend anything? Nope. It is a parent, it is not a child. And it has a name and a string, a name and a price. Ah, good catch. Good catch, ladies. All right. We forgot to make it abstract. Good. Is that really all that important? Yes. Yes, it is. Okay. Does that mean that it cannot have a constructor? Since it's an abstract class, can it have a constructor? Excuse me. Yeah, absolutely. Because since we made these variables private, our children will not be able to use them directly. So we will need to have some way to create a product with a name and a price using a constructor. So we will have to have a constructor for product with the name and the price, and with the name and the price variables. Okay. And then finally, we need to create our children product classes, right? Our clothing and food product. What was my things here? Is it size for clothing product? Okay, so that should be everything for clothing product. And then I'm just going to, for food product, I'm just going to copy and paste all of clothing product and just make some minor changes. So let's type, type. Okay. Oh, not food, not FOD product, food product. Okay, let's see if it builds. Oh, constructor product in. Oh, you know what I did wrong, right? Yeah, the compiler doesn't like that I called, because what was hidden here that we didn't see? this, right? And yet I don't have that type of constructor on my product. Okay. You're right. So we need to call the constructor explicitly. What I'm going to do is do this. All right. And I'll just do the same thing with food product here. And take this. Okay. If that works. Yay, now we're happy. He's gonna come out. He's coming out. Hold on. Yay, we're happy we made all our classes. All right. So let's see here. So we've made all of our classes. Oh, but we're not done with our diagram, right? There's a couple of things we didn't do yet, right? We need to have some way that the store can have customers and the store can have products. How do we do that? How can we have the store have customers and the store have products? All right, we could do an array list. We could do an array. We could do an array list. In a few weeks, we will also learn about other collections as well. But yeah, an array list sounds like a great solution to me. So what some of you may have figured out a while back is I have to import array list though. Or you have to use the entire thing. But anyway, all right. So what we'll do is we'll say we can do it this way, and then now we can either do it here. We can either have it created here. That's right. That syntax is correct. Yep. So we can either do it here or we can do it here and just have this be. Either way, this works, okay? And effectively, they do the same thing. And we're just creating a new array list for our customers. We can do the same thing for our products. So now this right here, this array list of products and this array list of customers satisfies this and this. Okay. So now at this point we have that, 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 we have that. All right. Okay, we have everything, right? We have everything. Everything. Are we done? Can we go home? Or, well, many of you probably already are home. What are we missing? Well, methods would be added too, but that'll be a discussion for a different day. Is everything on this diagram covered? And by the way, Recep, Summit, the array lists are what this relationship is. This relationship is what the array list means, right? So we don't add the array list as an attribute. We don't add the array list of customers as an attribute. This relationship here means that we need some type of collection, some type of list or array or collection that is contained in store that keeps a list of all the customers that the store is keeping track of. Okay. So the array list for customer is this relationship. The array list for product is this relationship. Okay. So the question is, as far as, you know, and we didn't add get and set methods because that's just busy work and tedious, and you guys know how to do that. So I didn't feel like I needed to do that in this class. Methods are another thing that we'll talk about, because I want to talk about that after the midterm, because I want to talk about how to do a flow chart for methods, because that's another UML diagram I will want you to know is the activity diagram. But as far as this is concerned, as far as this diagram is concerned, have we done everything? Does this Java code, you got it, Oslam, and Delara came in too. All right, yes. What we didn't do is we didn't say how the customer buys a product. Right? So what should we do? So because for a store to have a relationship with customer, we had an array list. For a store to have a relationship with product, we had an array list. What do we do here? Okay, what would we create a method? Now, all of this is not about methods and activities. This is about how to store the information. Can add a field, customer, and product. So like where would we add that field to? Okay, so Recep says add an array list to customer. Okay, what would be in that array list? Products. Yeah, that's definitely one solution. Since this relationship looks like it's just the same thing both ways, could we add a customer list in product to see what customers bought a certain product? But I mean, but products are bought by customers, right? All right. The reason why I asked this question is because there is not a right answer. Okay. A customer buys products. A customer buys products. Sure, they put it in their cart. All right. This is the list of all the products that the customer is going to buy. Sure. Okay. That's one possibility. We could also say, well, what I want to do is I want to put in the product here. A list of buyers who bought this product. Sure, that's an option too. I would say what seems more natural is that first option, right? Where we have a customer that has a cart that has a list of products. That makes the most sense. But now the question becomes, if I wanted to display, something like, let's say, right, the receipt, the fish, right, the fish, the hesap, I want to display, in fact, let's just call it that. Let's call it the hesap. Right? So I want to display all of the items that the customer bought, right? So what I would do is I would right? What I would do is I would say, okay, I'm going to not display, sorry. This is a string, right? I would take all the items in their cart one by one, and I would concatenate together into a hesap string, right? Into a receipt string, and then I would return that. Right? So if I wanted to see all the items that a customer is buying to give them a receipt, I could do that by having this array list, by having this list of products. Okay? But what if the store wanted to know that I want to get a list of all the customers that have bought Snickers bars? How can I do that? Would I have to go through the customer one by one? Did you buy a Snickers bar? 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 All right. Is that what I would have to do? Right, so if we wanted to know a list of all the customers who bought the product, oh yeah, then we would have to go to product and we'd have to add an array list of product. All right, so we could do that. Now, we could go through right? So now we could go through the list of customers and list off buyers. What's the disadvantage here? And the disadvantage here, and those of you who are also in my database class, this should be coming back to you. We've talked about this. Data consistency is a big problem in this solution because when a customer buys a product now in this way, the way that I've done this, when a customer buys a product, not only do I have to add the product to the customer's cart, I also need to add the customer to the buyer's list for the product. I need to do both. And if I don't do both, then I will have data inconsistency and I will have a data problem. Right? So maintaining data consistency becomes difficult in this situation. Right? So what's the right solution? And the answer, as it often is with things that we do, there is no one right solution. Most likely, what I would think would be probably best would be to not have this. That for those times when a store wants to list out all the customers that have bought a product, they actually do. They just have to go through their entire customer list and say, did you buy this product? Add them to the list. Did you buy this product? Add them to, and so forth to display that. Yes, it sounds tedious. It sounds time consuming, but because that is a less frequent request than for the HESAP from a customer, to me, it probably makes more sense. I'm not saying I'm right, but there are three we've talked about just now. We've just talked about three possible solutions. A single array list in the customer that tells me which products they've bought. A single array list in the product that tells me which customers bought that product. An array list in both. One that tells me which customers have bought a product, one that tells me which products a customer has bought. Right? So those are three possible solutions of how we could do this. They all have their positives and negatives. They all have their advantages and disadvantages. And those aren't even all the possible solutions for how we could do this. Okay, so as a little reclam, as a little advertisement for your future, and for some of you who are currently in my database class, right, when we start talking about database, this becomes a really good database solution, honestly. So, okay. So we talked about how to take this diagram and convert it into Java code. Right, the structural part of the Java code. Again, I did not include the get and the set methods. I only included the attributes themselves. Right. You would, if you were writing the system for real, you would need your get and set methods. You would need, stuff like that. You probably would have some methods defined, also some specific methods defined. But like I said, I want to hold that discussion for after the midterm because I want to teach that after the midterm and have that discussion then, because your next assignment that'll come after the midterm, your next assignment will be based on some of that. Okay? All right. Does anybody have any questions before we dismiss? Before we end for the day? And by the way, this diagram, I'm going to go ahead and save it. I'm going to save this diagram. Okay. Yeah, so I saved this diagram. Where are you? Okay. Over to this lecture examples folder. Okay, and also the midterm example Java code is there as well. Okay, so you guys have access to this in the lecture examples folder. and you should be able to have access to all of this, okay, to both of these examples we did here today. Okay. All right. Well, I'll see you guys in 1 week, and we will have our midterm, and we'll get going then. Thanks. Have a good weekend, and Yirmi Nissan. All right. Enjoy your holiday, even though you can't really go out and do all the things you normally would. But let's celebrate as best we can. All right. Thanks, guys.